Okay, homework 9 is on solving rational equations. So up at the very top of the notes, we had two different methods that we talked about. So method number 1 was the proportion method. This is best used in cases like these top 4 here, where you only have one fraction on the left and one fraction on the right. You could also, if you wanted to, you could condense so that you only have one fraction on each side, and you could use this method every single time. I'd say it's best not to mess with what it looks like initially, but it's totally your choice. So this one, number 1, is set up just with one fraction on the left, one fraction on the right. So we are going to cross multiply in order to solve. Okay, so cross multiplying, you would take these two, multiply them out, right? So 8 times m, and then cross multiply here, 5 times 2m minus 6, and then you basically just solve. You distribute, combine like terms, solve for the variable. With these ones, make sure you're checking for extraneous solutions because they can pop up here. Anytime you have variables in the denominator, you have the potential for extraneous solutions. So here, this is just, of course, an 8m. Here we can distribute that 5. You've got a 10m minus 30. And then we're going to solve for m. So I'm going to subtract 10m from both sides. So 8m minus 10m is a negative 2m equals negative 30. And then divide both sides by negative 2. So we get m by itself. Negative 30 divided by negative 2 is a positive 15. And you always want to check that answer. All you're checking for is to make sure that neither of your denominators would equal 0. Okay, so if I plugged 15 in here, my denominator would be 15. That's fine. If I plug 15 here, you'd have 2 times 15 minus 6, which isn't 0. So as long as it's not 0, then your answer is fine. Okay, so we've got our little solution set here. Just the one answer. All right, so that's the first type. That's the setup that you want to use if you have just one fraction on each side. I'm going to look on the second page at number 9. This is a different type. This is where you want to use method number 2, where you use an LCD. Okay, so you're going to multiply each side of the equation by the least common denominator and then solve what you end up with. So in order to find the least common denominator, you're going to factor any of the denominators that you possibly can. So this denominator is just an x. There's nothing you can do there. Same thing with this one. This one you can factor out a GCF. So the x squared plus 4x, they each have an x. And when you factor that out, you are left with x plus 4. Okay, so that's the factored version of that second one. All right, so what you want to do is figure out what the LCD is. So you just take the entire equation, left-hand side, right-hand side, and you're going to multiply by the LCD. I always find it's easiest to just kind of look at each denominator left to right and multiply in whatever is going to make it cancel. Okay, so this, I need an x to make this one cancel. I need an x to make this one cancel, but I already have it. I also need an x plus 4 to make that one cancel. Remember, your end goal is that all the denominators are canceling. And then for this one, I need an x, which I already have. Okay, so this is the least common denominator because it's going to make everything cancel, but it's not any bigger than it needs to be. So again, just kind of left to right, make sure each of the denominators is present in what I'm multiplying right here, but it's not any bigger than it needs to be. Okay, so you're going to distribute that LCD. So here I have, when I distribute with the 4, I have 4 times x plus 4 over x equals, and then do the same thing on the right-hand side, times 1 just means it's this exact quantity right here. And then here I have a 5, so plus, you should attach a 5 to the front of that, and then over x. Okay, so we do that. It looks messier than it was before, which as of right now it is, but then you have a lot of simplifying and canceling that you can do. So here we have these x's will cancel, and I can distribute this 4. So I have 4x plus 16, so no denominator, which is a win. These ones, x's cancel, these cancel, so you do have a 1 left behind. People will mess that up and say that there's nothing left behind, but there is actually a 1. Plus, and then here the x's will cancel, and I have a 5 that I can distribute, so 5x plus 20. All right, so then you just solve what we've got left there. So I'm going to combine the like terms on my right-hand side. So I have 5x and then the 1 and 20. And then I will solve for x. So I'm going to subtract this 4x from both sides. That leaves the 16 by itself. 5x minus 4x is x. and then I will subtract that 21 over to the other side. So 16 minus 21 is -5, and that leaves the x by itself. So just like I mentioned with the previous one, make sure that you're doing a quick check just to make sure your denominators aren't 0. So when I plug in -5, -5 here is fine. -5 squared is 25 plus -20. That's not 0, so that's fine. If I plug in -5 here, that's fine as well. All right, so just the one answer. I want to list it in my solution notation like that.